this one. Okay, now it's recording right now anyway. So from here we got all three vectors. Okay, side, side, side. Okay, that's enough to prove, right? That's enough to say these two triangles are congruent. So you can go triangle FK, or I'm going to borrow this one, FKE. That's the same things. FKE congruent triangle FKG. The region is side, side, side congruent. Or you can go also side angle side too. I'm not going to use this one because we got these two sides are congruent. Using these two sides, we can say these two angles are also congruent, isn't it? Okay, instead of this one, I'm going to this one jump over here 5. Okay, because these two sides are congruent already, you can see that EF, FG from here, right? You can see that angle E congruent angle G. What's the region? Do you guys remember this one? The region over here? We're gonna go jump. The angles opposite congruent side are congruent. To remember, right? I'm gonna show you this. Just a more minute. Can you see it over here? Isosceles triangle, angle ACB, angle ABC, right? In a triangle, congruent angles are opposite congruent side. Okay. Okay, better use this one. Okay, forget it. This one. Use this one. Okay. Angles opposite congruent side are congruent. Okay. All right. Now we got what? Side angle side. It's okay. Now you can go right same as this one. Triangle FKE and congruent triangle FKG. The region is what is that now? Side angle side. Okay. So there's two different ways. Okay, you can go side, side, side. That's the easiest way. Also, you can go side angle side too. Okay, using the property of isosceles triangle. Okay. Now we go next one. Still isosceles triangles. CA equals congruent to CB. Okay, that's the given. So I'm gonna write down over here. Given is isosceles triangle ABC, but you have to say this one, okay? Wait, what? CA congruent and CB. These two sides are congruent entire length. That's the given. A second one is M is the midpoint. This point, midpoint. From here you can see that these two sides is equal, right? Yep. M is the midpoint. Of AB. You write down, okay? From here, another one more given. AD congruent to BE. This is another given. Just a 1 minute. Okay, sorry about that. So Over here we got this one, AD congruent BE. Okay, our goal is triangle DAM congruent to triangle EBM, right? These triangles. You need to prove they are congruent. We already got two sides over here, okay? This is given already. This side given. Also this side, we are not done. Anyway, it's gonna be equal, right? Using midpoint. Okay, do this one first. From the midpoint, segment AM congruent MB. Okay, so you have to write the region. Okay, midpoint. Divides a segment into two congruent segment, or part is okay too. Okay, now we got two sides already. We need one more. Where is one more? Anybody can give me some idea? We need a three, right? First one is we can go side, three, side, angle, side, three, angle, side, angle, three, angle, angle, side, three. Okay, on right triangle you can use hypotenuse neck, but we have to go this way, right? That's not the right triangles. So we need one more. Where is it? How can you find one more? The other one more is not given. From the figure we need to find out. Anybody can give me the idea? Okay, okay, I'll be here, chat over here. EKF. That's a different one. Okay, anybody can give me some idea? To prove right triangles congruent, we need one more. We have only two SS. Where is one more? Can you guys find one more things? It will be segment. This is segment. We don't know. It didn't say anything about this one. Maybe angles? Maybe angles? How about that? Angles is okay. Angles is okay. Why? Because this is isosceles. Isosceles, what? Two congruent sides, opposite angles are congruent. That's the right theorem, isn't it? Okay, now we can go this way. Okay, it's already what CA congruent to CB up there. I'm gonna mark right red over here. Opposite side congruent. So you have to say number 5 there. Angle A congruent angle B up there, okay? What's the reason? Angles, I just finished this one. Angles opposite congruent side. I'm going to do symbol. Okay, I'm going to do this. These angles are congruent also. That's the perfect reason. Okay, you have to write down this one. Now we got everything: side, angle, and side. Okay, now that's enough to say these two triangles are congruent. Triangle DB, DMA, follow the order, right? This is better. And triangles EBM, they're congruent. The reason is what? Side, angle, side. Or you can use side, angle, side, congruent, side, angle, side. That's fine. Are you guys okay with this? Say something. You guys okay with this? You guys need a little more detailed expressions? Okay. Jay said yes. Kyora said yes. What about NA? NA? You okay, right? Okay. And you did good on your homework. I think you can do that this. Yes, okay, and I said yes. Okay, now move on next questions over here, okay? Take a look over here. QO over here, QO inside and the QN, they are congruent, which is what? This is kind of what? Not kind of, is actually isosceles, two congruent side. And the MO and the MP, they are equal side. Okay. So using these two, we're gonna prove triangle QOM. Where is QOM? Oops, not this one. QOM is this side. I'm going to QOM a little separate. Or they said over here to avoid confusion, we can just separating the triangles. This is the M, this is the O, this is the Q. And the next one is what? Q and P, right? Q and P. These two triangles, this one and the other triangle. Congruent. Okay. So how can you find the three factors of congruent? The first one, OQ. This is OQ. QN, they said they are congruent already. This is the 1S. Okay, so I'm going to write down there. QO congruent QN. Okay, QO congruent QN. That's the given. We got one side already. Okay, when you have a diagram, okay, some complicated, okay, or get mesh, you can separate. Okay, that's the easier way to look at it. Okay, the next one is about MO. This side, NP. It already says it said already equals. These two sides also congruent. We don't need to write line over here. This is already congruent. So we already have this one, MO congruent NP. We got two sides already. Okay. This is side, this is also side and side. We done. Circle is done. But we still need one more. Where is the one more? Can you guys give me the one more factor? This one we already only about two sides. We need one more. Where is it? Anybody can give me the idea? Q and P. Excellent. Q and P, this line, this angle over here. That is Q and P. This angle is how much? N. No, this is the Q and P over here. This is Q and P. This one is the Q and P over here. Okay, I'm gonna delete this one. This angle how much? MQP, right? MQP. MOQ. These two lengths, these two angles are equal, right? Actually, this angle, where is here? This angle here. You can see that, right? In isosceles triangles, opposite angles of congruent side are congruent. Okay. Anyway, we have two sides already. This is one side, another side. Now we're gonna go one more angle, O and Q, okay, or P and Q. It doesn't matter. I'm gonna use what P and Q is better, okay? Angle P and Q congruent. Angle QMQ, right? OMQ. This angle, these two angles are congruent. Okay, what's the reason over here? We already got these two sides are congruent over here, okay? From here we can say angles A lot. Okay, we did this a lot. Angles opposite, congruent side are also congruent. We did already, okay? Can you see that over here? Number 5, when you have isosceles, a lot of times, okay? They are congruent. The angles congruent. Take a look over here. Side angle. Everything's okay. Everything we got already. So now you can say enough to say these two triangles are congruent. Triangle QOM. It's okay. This triangle congruent. Triangle QNP. Right. This triangle. The region is what? It's very short, but the region is what it is. Side angle side. Okay. Side angle side congruent. It looks complicated, but only what 4 steps there. Okay, so the idea is what when you have a diagram get messy. Okay, try to separate the triangles. That looks easier. Okay, looking at it. Okay. All right, then move on next questions over here. Oops, what it is? Number 4. You guys take a look at this number 4 and think about okay which way you have to go. Side, angle, angle, side. Which one you have to check it out. Give me the method over here, okay? Side, or side, angle, or angle, side. Which one? Check it out. So if you give me the number method, we can go that way, okay? Okay, everybody try this one. Just chat to me which one is the best one. During while I'm going to write down what we given, okay? Okay. All three is given. Oops, no. This time we're gonna prove why triangle angle 1 equal congruent angle 2. Okay, we're gonna prove. Okay, these two. This is not like this one. Okay. Sorry, this is not triangles congruent. Okay. We try to prove right angle 1 congruent angle 2. Do you remember the rule over here? No, that is not angle side angle. Okay. Can you see that over here? Angles opposite congruent side are congruent. We have to use this one. Okay. Angles opposite congruent side. You have to say right. These two sides are congruent. That's right. You need to say it this way. How can you prove this one? CA and the DA, okay? Subtraction, okay? CA minus DA, they are congruent, and the CB congruent EB, isn't it? This was subtractions. Now the next one is, I'm going to use the partition postulate. Okay, this is also partition postulate. CA minus DA. CA minus DA is what? CD, isn't it? You can use, okay, CD equals what is that? CA minus DA. We have two different ways, okay? Partition is I'm going to this one. A and D and C. AC congruent sum of each part, okay? AD plus DC. It's okay? That's the partition postulate. Also, this is okay too. CD, I'm going to use the part of this one. AD equals how much? The whole minus the other part. Okay? Whole minus the other part. This is also a partition postulate. Okay? You can use either of this one. This one you set partition postulate. CD equals how much? CA minus DA, right? That is partition postulate. Another one over here. CE congruent to what is that? CB minus EB, right? That is the partition postulate. You can use it, go this way or the other way. But we know that CA minus DA was CD. You replace this one, okay? So that is a partition postulate. Anyway, this one is partition postulate. After that, CADA is replaced with what CD. That is a substitution. Okay. So this one is CD. The other one is over here CE. Okay. CD equals CE. They are congruent. That is what is that? Substitution. That's enough. Or sometimes congruence, because they are congruent. Okay. Now we got the CD and CE congruent. I'm going to change the color over here. Now from these two congruent, opposite angles are also congruent. That's the rule, right? Okay, now you can say that angle 1 congruent angle 2. From here you can say this one. Why? The reason is what? Angles opposite congruent side are also congruent. Are congruent. That's a symbol. Okay, we're done. It is okay. But usually corresponding angle, this is not corresponding angles. Angle 1, angle 2 is not corresponding, okay? That's why we have to go this one. To prove right corresponding parts are congruent, we have to go, okay, the CPCTC after what? Prove triangles are congruent, okay? So we're gonna have another example for that. Okay, after this we're gonna do, okay? Supplement first. These two angles are linear pair. Linear pair means what? These two angles are supplementary. In measure, what can you say? Sum of these two angles is 180, okay? So you can solve this one. Maybe we have some practice on this one. This side, okay, 4x plus 10, and this one 2x plus 60. But another over here, angle CDB, angle CBD, they are congruent, okay? But all together this is a supplementary angle, but this is a congruent. The other supplement still are congruent. That's our rule, right? Using that rule, you can find the value of x. 4x plus 10. That the supplement of this angle must be equals to x plus 60. Okay, so you can solve this one. Minus 2x minus 10, x equals 25 degree. It's okay? That's fine. So we go move right the next improvement. Okay, ABCD is a straight line. Okay, you have to give this one first, and then angle 1 and 2 are supplementary angle because they are linear, right, on straight line. Angle 3 and 4 linear pair, then these two angles are supplementary. Okay, so from here we can prove, right, angle 2 and angle 3 congruent. Okay, it's very simple, but there's steps. You need to follow the steps. Okay, I'm gonna write down over here a little thick this. Number 1. A, B, C, D. Straight line on the line. Okay. Now number 2. Angle 1, angle 4 are congruent. This is a given. Second also given. Okay. So what's the next? What's the next? We have to say angle 1 and 2 are supplementary, right? So you can write down over here. I'm going to write down angle 1 is, we already said they are congruent. Take a look at the other angle, 2 and 3. So angle 2 is supplementary. To angle 1. It's okay. Another angle 3 also is supplementary to angle 4. Okay. Why this is supplementary? They are linear pair. Okay. Angles you have to memorize. Okay. Angles that form a linear pair. These angles are supplementary. Okay, memorize the reason. Okay, that's why angle 2 is supplementary to angle 1. Okay, now you can make conclusion over here. Angle 1, angle 4 congruent. These two angles congruent. It's like supplement also congruent. You can say now angle 2 congruent to angle 3. The reason is what is that? Supplement of congruent angles are congruent. That's all. We finished. Okay, it's very simple, right? That's why when you have a supplementary angles, how we handle this one, you have to memorize the step over here. Okay, always was supplementary, the region over here. Okay, and the supplement of congruent angles are also congruent. You have to memorize the region. Okay, over here. All right, move on to the next one over here. Okay, everybody take a look at the figure and try to find which method. Okay, because at this time triangle ADB over here, right? ADB and the CDB, CEB congruent. We have to show this. Okay, now take a look. They're given over here. This is straight. Now we can use what they are linear pair, right? Angle 5, angle 3, because they stand on straight line, they are linear pair. 4 and 6 also linear pair. So angle 5 and 3 and angle 4 and 6, they are supplementary. Okay. Okay, AD equals EC. You got the one side already. I'm going to use side. You got the one side already. That's all done. Angle 1, angle 2. Oh, this angle also what? Done. Now we have angle 3, angle 4 is there, right? But to prove right they are congruent, we need to say right this angle and the other angle 6 congruent. So which is what is that? Angle side angle, isn't it? So we can go angle side angles. Okay, now let's prove this one. Number 1. Given is ADEC. And second one is AD congruent EC. This is already done. Perfect. Circle. Second one, third one is angle 1 and congruent angle 2. This is already done, one angles. This is already done. The third one, we need one more, okay? we got the one side, one angles. We need one more. This is the angle 5 and 6. It's okay. So we have to prove angle 5 congruent to angle 6. How can you prove this one? Angle 3 congruent to angle 4. Using this one, we can find the supplement also congruent, okay? Now let's find. This is not done, okay? Now number 5. Angle 5 is supplementary. I'm going to use the SPP, okay? That means what? Supplementary to angle 3, okay? And also angle 6 is supplementary. It's a supplementary to angle 4, isn't it? These two angles are congruent. We know that. It's supplementary, also congruent, okay? So if the region over here, what are the angles? We did already, okay? You have to memorize this one. Angles that form, because that's a straight line, linear pair, okay? A linear pair. The angles are supplementary. Now 6 finally we can make conclusion there, okay? Angle 3, angle 4 congruent. It's a supplement. Two angles are congruent. Angle 5 congruent to angle 6. The reason is what? Supplement. You have to memorize, don't change any word. Supplement of congruent angles are congruent. Don't change any word, okay? Supplement of congruent angles are congruent. Exactly, it should be like this one. Now we got the angles of 5, 6. That is one angle. Done. Angle, side angle. Okay, we got everything. Now we make conclusion, okay? Triangle ADB congruent. Triangle CEB. The reason is angle, side angle, congruent. Is okay? So when you have a supplementary angle, you have to follow the step over here. Remember. And also memorize the region over here when you have a supplementary angle. Is okay? Don't change any word. Okay? The region should be exactly like this one. Okay, after one more, we have some break, okay? I understand you guys are very tired. After this, we'll have some break, okay? Now, I'm going to write down the given first. EG is perpendicular. EG. This is a perpendicular bisect. Wow, this is a perpendicular bisect. Together. Of AB. And second one is angle 1 congruent to angle 2. This bisector means what? These two angles are perpendicular, and bisector means what? These two sides are congruent. That's the meaning, right? And also angle 1, angle 2 are congruent. Okay? Now this is not supplementary. This is what? Complementary, okay? We just finished with the proof of a supplementary angle. Now we have complementary angles. You gotta be careful. Complementary is what? Sum of two angles are right angle, okay? The angles that form right angle, not linear pair, okay? Okay, over here, keep it. Okay. Angle 1, this is given, that's fine. So, which way we have to go? Yeah, we got one side already. Not finished yet. Still, we can guess one side. And DF, also CF, right? These two sides are also equals. two sides. This is done. Okay, this is already done. DF congruent HCF, they are done. This is finished. From the given, it's all finished. Always what 2 out of 3 always given, right? You can see that. We need one more side. We got the side. We need one more this angle, isn't it? Using complementary angle, right? So this one go to what? Side angle side, you can guess. Side angle side. It's okay. We got the one side already. And from the bisector, we can say AF. Now we can go over here. AF congruent FB. It's okay because this is a bisector. This is a segment bisector. Okay, so we can write down over here segment bisector. Device. I'm going to simplify. Okay. Device a segment into two congruent segment or part. This time I'm going to use a part. You can use a segment, it doesn't matter, okay? Now it's done. Now we have two sides. We need one more, which is the angle, right? Okay. Number 5, we gotta go to find these two angles are equal. I'm gonna let this is what? I'm going to this one. Simply 3 and 4. Or you can use the angle DFA, okay? Angle 4 is what? Angle CFB. I'm gonna choose okay, make it easy. Okay? I'm gonna use angle 3, angle 4, okay? Alright. So angle 1, angle 2 it's given. So you can say that angle 1, angle 3. Angle 1 is, I'm going to do angle 1, angle 2, okay, angle 3. Angle 3 is complementary. Same as before, right? Supplementary. Complementary to angle 1, okay? And another angle 4 is also supplementary to angle 2 over here, isn't it? What's the reason over here? What is the reason? Angles same as before, okay? Angles that form right angles. Right angles, these angles are complementary, okay? Because there is a right angles. Okay? That's what we said, complementary angles. Now we know that angle 1, angle 2 complement over here. That is a congruent. So each complement should be congruent. Now fine, you can say angle 3 congruent angle 4, right? The reason is not supplement, complement. Of what? Congruent angles are congruent. Now this done. Now we got everything, side angle side. Now it's enough to say these two triangles are congruent. Triangle ADF congruent, triangle BCF, they are congruent. The reason is what? Side angle side congruent. It's okay? When you have a complementary, you have to go these steps. Okay? But remember, some teachers, they use different reasons. But this one is what? Very formal. Every 99% teachers, they use this symbol. They use this way the given. Okay? Some other teachers, they want to go easygoing. Okay? Easygoing means what? Just they say definition of a complementary. Definition of a midpoint, definition of perpendicular, just like easygoing, but that's totally wrong. But if your school teacher go each way, there's no choice. You have to follow your teacher style. Okay. All right. That's all we prove on this question number 3. Okay. So we're gonna have some break because you guys I know so tired. I'm gonna. Okay, now back to work. Number 4. Angle D, angle B, both are supplementary to angle C. These two angles supplementary to angle C of there. That's the given, okay? I'm gonna write this one. Angle D and angle B, I'm gonna separate, okay? Okay, I'm gonna write up this first. That's wrong. AD congruent AB. That's the given. The second one also the line segment DF congruent BE. Okay, AD congruent AB. This is already one side already. Okay, we got the one side done because we prove a triangle AD. This one. Okay, yeah. DF and BE congruent. It's already done over here, okay? So also this is done, this is done. But we need one more. We have right side and side. Between side, these two angles, we have to say congruent. Okay? Now that's all today. Okay, now number 3 is what is that? Write down there given over here. Angle D is supplementary supplement to angle C, and the angle B also is supplement to angle C. Okay, that's the given. From here we can say, right, this is already given. Okay, we don't have to say linear. Okay, from here this angle is congruent. Okay, but they are equal, same angles. So it's right, supplement also equal, right? You can say angle D must be congruent to angle B. You know, what's the reason? The reason is a little bit different. Just before was supplement of congruent angles, but this is not congruent. They are equals. We said of the same angles. Okay? It's a supplement still congruent, are congruent. Okay, that's the reason. A little different, okay, because the angle C equals the angle C, it's the same angles, okay, but use these regions. So we got everything, side, angle, side, okay. Now we can enough to say these two triangles are congruent. Triangle ADF congruent, triangle ABE, okay? The reason is what? Side angle, side congruent. It is okay? Now move to the next one. Okay, I'm not gonna, okay, try just only one, okay? But I'm going into focus right more proof, okay? But this is okay. Just try this one. Angle, this is the measure means what? The number, right? Okay. FAB, this measurable angle is 48 degree. I'm gonna make it big. That's better. This is recording, right? Okay. And the angle ECB. Where is ECB? ECB, this angle. This angle is 18 degree. And what is the measurable angle ABC? ABC, this angle. Okay? But we already this one, right? That's right. Maybe first, maybe you can use like exterior angles. Okay, I'm going to use exterior angle first. exterior angles, this is 48, this is also 48, right? Alternate interior equals are congruent. It's okay? This is alternate interior angles. But this angles is already extended one of the side and another side that forms an exterior angle. This exterior angle is sum of these two remote angles, okay? 48 plus 18 equals to 66 degrees. That's the answer. It is okay? Right. I'm gonna delete, okay? Anyway, the answer is 66. I'm gonna go a little different way. Use this will make the one more parallel line there. This is parallel line, this is alternate interior 48 degree. This is 18, another over here another alternate interior angles. 18. Sum of these angles how much? 48 plus 18 still 66 degree. You can solve this way too. It is okay? Alright. Now we're gonna move on. Proof, okay? Oh, this is not proof. This is a proof over here. All right. Here given. You know that, right? Given. ABC is the line, straight line, and DF also straight line. Okay. Then we can say these two angles are linear pair, right? Linear pair. They stand on linear. Okay. So that's the given anyway. Second, angle 1 congruent angle 2. This angle and angle 2 congruent. That's the given. The third one, angle 3 congruent angle 4. These two angles are congruent. Okay, that's the given. So we're going to prove a triangle BCF, this triangle, and EFC, this triangle is congruent. We already got one angles there, right? We already got one angles. Where is it? Angle 3 and angle 4. This is done. One angles already. Using supplementary angles, we'll get another one more angle over here, okay? We'll get another one more angle. Using supplement. This is already what? Angle. We are not done anyway. This is another angle. I'm going to use the little a, okay? We already use by a there. This is done. So we have two angles. We need one more. Where is one more? Because to prove triangles congruent, we need at least one side. We only have two angles. We need at least one side. Where is it? CF, isn't it? CF to this side, the other side, they are same length. This is what? Reflexive. So we're gonna go what? Angle side. Angle side. It's okay? Okay, now 3 and 4 is done. Now we're gonna try the next one. CF, reflexive first, CF congruent to CF. That is equals to reflexive property. This is done, okay? One side is done already. Now we need one more angle over this angle, right? Now we're gonna make it. Angle 1 and angle, I'm gonna use CBF, okay? So I can say angle CBF is supplementary to angle 1, okay? So the next one is the angle CEF. Angle CEF is supplementary to angle 2, right? What's the reason? linear pair, right? We have to memorize angles that form a linear pair, that angles are supplementary. Okay. Also, instead of this one, you can use this one too. Angle CBF and angle CE, angle 1 are supplementary. It's okay, right? Anyway, okay. But I'm gonna use this one first. Okay, now we know that angle 1, angle 2 congruent. These two angles are congruent from here. So it's a supplement still congruent, right? So you can say angle CBF congruent angle CEF. The reason is what? Supplement of congruent angles are congruent. Now this is done now, circle. Okay, when it's done, that is circles. So we already done 3 already, right? Side, angle, angle, or angle, angle, side. That's enough to say triangles are congruent. So triangle BCF, congruent, triangle EFC. So the reason is, what is that? The reason is angle, angle, side, congruent, okay? Move on to the next one. Let me see how too much. Okay, overlapping will be next. This one. AD perpendicular BC, okay? AD perpendicular, this is what? Perpendicular. Complement. Second down. AD complement BC. And angle 1 and congruent to angle 2. And third one is AD bisect angle BAC. So that means what? These two angles must be congruent. Okay? So we have to prove a triangle AED. This triangle, the other triangle congruent. From the what complement, this angle 3 angle form must be what congruent. You have another angle congruent, we already did, okay? We already have that. And this one goes to an angle, this side is what? Reflexive. We can go side, angle, side, angle, okay? Angle, side, angle. But we have to use a complement. Okay, so from here, I'm gonna use what this complementer, okay? So this is a perpendicular means what? Angle or BDA, right? BDA or ADB. I'm going to ADB. Angle ADB and angle ADC are right angles. They are all given. This is given, this is given, this is given, this is what is there. Right angles is a perpendicular lines form right angles. But in this case, so we don't have to prove right they are congruent. Okay, but that's not what we want. We need to find these two angles congruent, that's it, okay? Not right angles. So the next one over here, angle 3, because they are right angles, angle 3 is supplementary, complementary, sorry. To angle 1, okay? And also angle 4 is complementary to angle 2, isn't it? It's okay? There's complementary angles. The reason is right there. The angles that form right angles. These angles are complementary, okay? Now these two angles congruent, each complement also congruent. So you can say angle 3 congruent to angle 4. The reason is what? Complement. Of congruent angles are congruent. That's the reason. Now this is done. I'm going to circle done. Okay. Now reflexive will be done. Okay. As dA congruent also dA. That is reflexive. Now finally I'm going to prove these two triangles are congruent. Okay. From here I'm going to see that. Okay. Make small, a little small. Okay. Okay. Angle EAD. Okay. Congruent angle FAD. These two angles are congruent because what? This angle bisector, okay? Up here, okay? Angle bisector divides an angle into two congruent angles. So we here write down the region angle bisector. Divides an angle into two congruent angles. That's why they are congruent. Now we got everything, okay? Angle, side angle, okay? That's enough to say the triangles are congruent, okay? Triangle AED congruent, triangle AFD, okay? The region is what? Angle, side angle. Okay, that's all. Now move on to the next one over here. After this repeats today, okay? Because next times you're gonna go overlapping and using CPCTC, okay? Okay, JX congruent to JY. JX congruent to JI. That's the given. Second one is KX congruent to LY. These two sides congruent. That's the given. So we're gonna prove, right, triangle JKX. Where is JKX? This triangle. The other triangle. But you already got two sides already, okay? This is done. This is done. Two sides. This is a side. This is a side. This is another side. Another side. We got two sides already. But we need one more up there, okay? Where is one more? Where is one more? They said anything about the angle 1 and 2? They said? Did they say right angle 1 and congruent angle 2? No, they didn't say about these two angles, angle 1 and angle 2. They are congruent. We don't know. But we know that these two sides are congruent, okay? Do you remember? The angles opposite congruent side are equals. Okay, using this one you can say angle 1 and angle 2 congruent. Okay, you can go directly angle 1 congruent to angle 2 because these two sides is set from here congruent already. Okay, the reason is what is that? Angles opposite congruent side are congruent. That's perfect region, okay? Are congruent. But we need what this angle, okay? Not 1 and 2. So we have to go the other way, supplementary angle, okay? So you can say angle 3 is supplement. Okay, I'm going to supplementary to angle 1, and angle 4 is supplementary to angle 2. Equal, okay? Why they are supplement? Angles that form a linear pair are supplementary. It's okay. Now premier find, we can say angle 3 congruent and angle 4, right? The reason is what? Supplement of congruent angles. These are congruent angles are congruent. Now we got everything, okay? Side angle side. Now you can say they are, the triangles are congruent. Triangle JKX congruent, triangle JLY. The region is what is that? Side angle side. It's okay? All right. So we're gonna do overlapping triangles, okay, with CPCTC next time, okay? Okay, I'm gonna send out this class note to your email, okay? But homework is just to go over by yourself one more times how you prove, right, all these triangles, okay? And try to memorize the region and steps, okay? Already there's a rule to prove, okay? You cannot use your own rule, okay? You have to use what is already proved, okay? You have to follow the rule, okay? So I'm gonna send out this one right away, and I'm gonna post via this lesson video on YouTube, okay? If you need to see the video, you can click the link, okay? I'm gonna send out after class. Okay, I think that's all today, okay? All right, now let's paste this one. Okay, okay, I'll show you next time, okay? All right, thank you everybody. Okay, you guys have a good night, okay? Thank you.